Hello, everybody. So, today we'll be learning about something new, and that new topic is probability. So, this will be, as you see indicated, just an introduction. I actually think probability can be very complicated, very difficult. And even in our class, which is just an introductory class, uh, even then, in that context, I still think probability can be pretty tricky. All right. But we'll start very simple and gradually work our way through it. Okay. Now, um, just about any time you're learning something new in math, um, it usually starts with learning what some of the symbols mean. You know, math is full of symbols, right? You open a math book, and if it's not something that you're already acquainted with, then you'll see a lot of symbols that you've never seen before, and that might make it look difficult. All right. So part of math is just learning the symbols. All right. Now, so let's say that one fundamental concept about probability is that of an event. Okay, an event is something that can happen. All right, when we write P in parentheses E, that's the probability of event E happening. Okay, so that's just what that means. The probability of event E happening. Or event E, like whatever you write in there. I might say, suppose we have a standard 52 card deck, and what's the probability that I randomly draw the card 7 of hearts? Okay, so that's just what that means when you see it. Now, the way you calculate the probability of an event E happening is you take the number of ways that that event can happen. There may be more than one way that the event can happen. And you divide that by the total number of possibilities. Okay? All right. Now that's how you calculate it. This is called the classical probability definition. We'll expand on this a little later. Okay? But for now, we're going to stick with just this. Okay. Now, suppose we do have that standard 52 card deck. Now, for the purpose of the video, I got a deck of cards, a standard 52 card deck. I have it ready to go in case I need to show you something. But I wonder if you're unfamiliar with it, because I can't assume everybody's familiar with a deck of cards. Maybe you're not. Here's what it contains. The deck of cards I'm talking about has 4 suits, okay? We got the clubs, the diamonds, the hearts, the spades, and for each suit, we have ace, 2, 3, 4, 10, jack, queen. That's 13 cards in each suit. So 13 clubs, 13 diamonds, 13 hearts, 13 spades. That's 52 cards. All right? Okay, so now in our book, you can find a diagram like this. And, it's like found that on Wikipedia. So there's lots of places you can find it if you need to look at it, if you're unfamiliar with it and you see a problem come up. Okay? All right, anyway. So let's start with the deck of cards, because I do think that most people are familiar with this. Okay? So I think it's a good place to start. We're also going to use a dice, a 6-sided dice, because I think that's probably also something people are familiar with. So let's go through some examples of this so you can see what I mean using something that you are familiar with, a deck of cards. So what's the probability that we draw a 7 of hearts? So I got the deck right here, and suppose I cut it and shuffle it, and so on. Suppose I do all that, and then I just take a card at random. What are the odds? That's the same as saying what's the probability of drawing a 7 of hearts? Well, okay, let's use this. How many ways can I draw a 7 of hearts? There's only one way for that to happen. If I draw a card randomly out of this deck, there's only one way I can get that 7 of hearts. There's not 2 ways. There's definitely not 3 ways, okay? You pick a card, and it's either the 7 of hearts or it's not. So I put a 1 there, okay? But what's the total number of possibilities? Well, if I'm going to draw a card, I could draw up any of those 52 cards. There's 52 possibilities for what I'm doing. So it's 1 out of 52. All right, so 1 out of 52. We may sometimes give our answer in terms of a decimal. Let's show it. There we go. So like 0.0192, okay? if we round it. All right. And sometimes we might give our answer as like a percent chance. Okay. So that's the decimal. And if I turn that into a percent, that's like 1.92% chance. So we may sometimes do that. All right. But those are all basically equivalent. 1 out of 52 chance, decimal probability of 0.0192, or a 1.92% chance. Almost 2% chance. All right. Anyway, okay, so let's see. There's my first example of this. Now, could we talk about events, okay, event E, where event E can happen in more than one way, right? Here, drawing a 7 of hearts, there's only one way that can happen. So what about this? Suppose you got your deck right here. What's the probability that you pick any heart? Like you just draw a card and it's a heart at all. Okay, well, all right. So remember, I said there are 13 cards of each suit. Okay, so there's 13 hearts. So for me to draw a heart, any heart, there's 13 ways that can happen, but there's still 52 possibilities at all. So it's 13 out of 52. Now, if we do a little more math, that reduces to 1 out of 4. Okay, if you simplify that fraction, that reduces to 0.25, or you could say a 25% chance. Okay, so those will all be equivalent ways of saying it. I got a 1 out of 4 chance of drawing a heart. I got a 25% chance of drawing a heart. You see? Well, that's not real good. I mean, my chances of drawing the 7 of hearts are pretty bad, 2% chance. Probably drawing any heart. Well, I got a better chance. I don't know. Let's see. This wouldn't really prove anything, but okay. Well, I have a 3/4 chance of not drawing a heart. Okay. All right. So let's do this. Let's increase our odds even better. What's the probability of drawing any red card? All right, now think back to that picture I showed you. The red suits are diamonds and hearts, okay? And there's 13 diamonds, 13 hearts. Those are the red cards, at least in the standard deck, okay? And so that makes 26 ways I could draw a red card out of 52 total possibilities. All right, so that would be reduced to 1 out of 2, okay? That would reduce to 0.5 as a decimal, or as a percentage, a 50% chance. Oops. Okay, so I have 50% chance of just drawing a red card. So my odds are getting better. Now, I was hoping as I went along that, well, when I talked about the 7 of hearts, drawing that, I don't have a good chance of drawing that. When I picked a card at random, it wasn't 7 of hearts. My odds are a little better of drawing any heart. Okay, 25% chance of that. I tried it. I didn't draw a heart. But I got even better odds of drawing any red card. I got a 50% chance of that. And I don't know. Let's see. Now, this still wouldn't prove anything, but let's see. So I had a 50% chance of not drawing a heart. Or, sorry, not drawing a red card. And then, okay, so I got, first one wasn't, second one was, 50-50. Anyway, okay, so there is our basic definition illustrated with a deck of cards. All right, now I'm afraid, like, when you see examples when you're practicing, you might see choosing random numbers, you might see a deck of cards, you might see rolling a 6-sided die like this. It's got the numbers 1 through 6 on it, okay? You roll it and a number comes up. It's random. We use it in games because it's very hard to roll a die and get it to land the way you want to. Although there are people that claim that they can, all right? So anyway, let's practice that same thing, that the probability of an event E is the number of ways E can happen over the total number of possibilities with a die. Okay, so let's see. What are the odds? What's the probability that you roll a 2? Well, so let's see. There's only one way that you can roll a 2. So 1, all right? But there's, what's the bottom number supposed to be? The total number of outcomes, the total number of possibilities. Well, there's 6 sides of this thing, so there's 6 possibilities. So that'd be 1 out of 6, okay? Now, what about roll any even number? Okay, so, I've got the numbers 1 through 6 on here. And so that would be kind of like saying, let's see, I got 1, 2, 3, 4, 5, 6. Those are the numbers on my die, okay? And to roll an even number would be not the 1, not the 3, not the 5. So it'd be 2, 4, and 6. So there's 3 ways I can roll an even number, but again, there's 6 total outcomes. So I got 3 out of 6 chance, or 1 out of 2 if I reduce that chance, or 50% chance of rolling an even number. Oh no, let's see. 4, okay, well I had a 50-50 shot of rolling an even number, any even number, okay? All right, so let's see. Let's do, okay, I got 2 kind of strange examples to show you. So far, these are like kind of a lot like the card deck, but let's look at these. So yeah, we encounter stuff like these last ones. So let's see, what are the odds, okay, with the dice I've got right here, that you roll a 7? Okay, well, I would say that's not possible. Without doing any math, just common sense tells me you can't roll a 7. It's impossible, right? So, but let's fit that into the way that we're doing things right now. How many ways can you roll a 7? 0, you can't. There's no way. There's not a single way you can roll a 7 on a dice like this. And then there's 6 total outcomes, and if you take 0 and divide by 6, you get 0, okay? Sometimes people have trouble with zeros when they do math. So, you can do 0 out of 6. And you get 0, right? Okay, 0 out of 6 is 0. And then as a kind of a complementary case, let's say, what's the probability that you roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6? Well, you're guaranteed to do that. You roll this dice, one of those numbers is going to show up. So there's 6 ways that event can happen. You roll 1 or 2 or 3 or 4 or 5 or 6. And then there's 6 total outcomes. So 6 over 6 is 1. Okay? So then looking at these, this is like a 0% chance. And this is like, if you convert 1 to a percentage, this is like 100% chance. Now, so these are the extremes for probability. 0 means impossible. So the StatCat's going to tell us a little bit about this. If an event is impossible, its probability will be 0. So if you know it to be impossible already, you can just state it to be 0. And if an event is certain, the probability is going to be 1. Okay? And then everything else is somewhere in between. All right? So for any event E, its probability will be somewhere between 0 and 1. It will be 0 if it's impossible. It will be 1 if it's certain. And then everything else is somewhere in between. Could be 50%, that would be 1/2, 0.5, that's between 0 and 1. 75% chance, 3/4, that's between 0 and 1. You get the idea. Okay, so I guess I didn't have to use these fractions. If I knew this one was impossible and that one was certain, I could have just said 0 and 1. All right, that's fine. Now, at this point, you might say, well, look, you're not accounting for all the possibilities here. Are there really only 6 outcomes in rolling a die? Think about that. Are there really only 6 outcomes? I got 6 numbers here, but when I roll a die, is one of those gonna come up? You might seem so, but what if I roll it and it rolls off the table? Okay? And you lose it or something. That's one of the outcomes. It could happen, all right? But when we take into account this definition of probability, we won't worry about that, okay? So later we'll worry about that, well, yeah, when you roll a die, one of the numbers 1 through 6 could come up, or you might roll it and it falls off the table and you lose it, or somebody runs by and steals it from you. I mean, I can't say that those are the only outcomes, okay? But for now, that's what we're going to say, okay? All right. So let's talk about something called the fundamental counting principle, because sometimes we need to deal with events that happen in ways, like too many ways for us to count. Like here, I can count the 6 sides of the die. It's not hard to look at it. And even with a deck of cards, there's 52 cards in the deck, but even then, like I can look at that picture I showed you on Wikipedia and I can see all of them. It's not that hard to see all the possibilities. So the counting principle is for counting events where there's just too many, okay? And I'll show you an example. It probably won't do much good to explain it. You need to see it by example. So let's say that suppose you randomly choose a number from 0 to 7. Well, that's not that bad. There are 8 different ways that can happen, right? Because you could choose the numbers 0, 1, 2, 3, 4, 5, 6, 7. So 8 possibilities. What about choosing a number from 0 to 9? Well, that can happen 10 different ways. You see, because you can choose 0, 1, 2, 3, all the way up to 9. Now, where this might get complicated is this, or something like this. Choose a number from 0 to 7, and then choose a number from 0 to 9. This is kind of like if you were choosing a password, in fact. When you make a password, you can choose from a letter of the alphabet, then another letter of the alphabet. And then now, maybe you can choose from a letter of the alphabet or a number, 0 through 9, or a special character like an exclamation point, a $sign, right? But that's how you would construct a password, is choose a symbol, then choose another symbol, then choose another symbol, however many characters your password is. Okay, so this is like that. Suppose we choose a number 0 to 7, and then we choose a number 0 to 9. So that'd be like kind of a 2-digit PIN number or something like that. Now, that would be you could choose 0, 0, 0, 1, 0, 2, you could choose 1, 0, 1, 1, you could choose 7, 9. I can't write down all the possibilities. It's inconvenient. Now, here's how you calculate the number of ways that can happen. It's called the fundamental counting principle. If event A can occur in X ways and by itself, and if event B can occur in Y ways by itself, then the event A and then B can occur in X times Y ways. So that's exactly what I'm talking about here. So choose a number from 0 to 7. That can happen in 8 ways. And then choose a number from 0 to 9. That can happen 10 ways. So the ways that can happen, you see what this looks like? Choose a number from 0 to 7, and then choose a number from 0 to 9. That can happen in 8 times 10 ways. That can happen in 80 ways. There's 80 possibilities that you can get from doing that. Okay? All right. So that's the fundamental counting principle. So whenever we are doing one thing and then doing another, and then even if you got a third thing, you just multiply by the third number. Take each way number-wise the individual event can happen and multiply them together. All right? Okay, so now here's where we might use that in our probability calculations. So let's say that my event, my experiment, the thing that I'm doing is like what's up there. And I want to randomly select an integer from 0 to 7 and then randomly select an integer from 0 to 9. Okay? All right. What's the probability that I select a 5 both times? Okay, so let's see. How many outcomes are there? How many possibilities are there? Well, here's all your possibilities, right? We determined up there that there's 80 possibilities. 80 ways it can work out if you randomly select a number from 0 to 7 and then randomly select a number from 0 to 9. Okay? But, okay, now the top is what? How many ways can this event happen? How many ways can you select a 5 both times? There's only one way for that to happen, right? You select a 5 on the first choice and a 5 on the second. There's not two ways that this can happen. So our definition turns out to be 1 out of 80, okay? And maybe that's why you see with passwords, passwords have gotten longer and longer over the years. So, maybe it was just letters at first, and they said, well, now you've got to add a number. And then they said, well, now the password needs to be 13 characters or whatever, and now you have to add a special character like an exclamation mark. Well, the more symbols there are to choose from, the bigger these numbers are, and the larger that number in the denominator is, and the smaller the chance is of just a random selection of your password, okay? Because it's always going to be 1 out of something. And as that number gets bigger down there, then it becomes less likely that somebody just stumbles upon it or guesses it at random by brute force, maybe by use of a computer or something like that. Anyway, so I'm curious, what's 1 out of 80? 1 out of 80 is 0.0125, okay? So that's 0.0125, all right. So that's like 1.25% chance. So if somebody was just to guess your password or try guessing it, they'd have to 1.25% chance of getting it, all right? Which means, if they tried enough, it wouldn't be that hard to get it. It's like 1% is like 1 out of 100. Maybe after 100 guesses or so, they get it. They could just go through them in sequence and so on. Especially if a hacker was trying to get it, password like that wouldn't take long at all. Anyway, okay, so that's our basic introductory lesson on probability. I want to leave you with this for now. This and the counting principle will get us pretty far with stuff that we do in probability. And we'll talk about the complexities of this in the next video.